Oxidizing versus reducing agents. So agents just like 007, old Jimbo Bond, well, there are oxidizing agents and there are reducing agents. Oxidizing agents act on other chemicals to oxidize their chemical. Act on another chemical to oxidize the other chemical. They get reduced. That's the key. Whenever it comes to oxidizing agents, it's important to remember that an oxidizing agent gets reduced. An oxidizing agent is the thing that makes something else get oxidized. Now, good examples of oxidizing agents that you'll see pretty commonly, well, O2, as you would imagine, is an oxidizing agent. It adds oxygen. NaOCl, your household bleach, your sodium hypochlorite, is an oxidizing agent. Cl2, Cr2O7, MnO4, these are all oxidizing agents. Now your reducing agents, well, these are going to act on another chemical to reduce the other chemical. So these get oxidized. Lots of questions related to this. This terminology will be identify the oxidizing agent to identify the reducing agent. Common reducing agents are carbon, H2, magnesium, and Zn. Now think about this in terms of, well, Mg as a solid or zinc as a solid. Well, those two things tend to get oxidized very easily. So they are going to give up electrons, and therefore they're causing something else to pick up those electrons. Now an example that you might want to look at is a balanced redox reaction. What species is the oxidizing agent? Which species is the reducing agent? So this is the sort of thing where we're bringing back some of the ideas of what is your oxidation number. If we look at what I always like to do is find the species that's kind of hanging out by itself. And I see iron going from Fe2 plus to Fe3 plus. So what that means is that, let's just say that this has, it does not have this many actually, so I want to get the actual number. So I'm going to pull up a periodic table. Iron has a total of, that would be 26 protons. An iron atom has 26 protons. And it's also, in this case, or sorry, if it were neutral, it would have 26 protons, 26 electrons. But it does not. It has 26 pro. And this is always confusing because previously we've talked about protons as hydrogen ions. But we're talking about the subatomic particle of a proton. This has 26 protons, which are positively charged, and 24 electrons, which are negatively charged, which is where we're getting this +2 charge from. Now, over here, we've got an iron with still 26 protons, so I'm just going to label it a positive charge, and 23 electrons, which is where we get the +3 charge from. So we've gone from 24 electrons to 23 electrons. So what has happened from Fe2 plus to Fe3 plus? We've lost 1 electron. So by this iron losing an electron, it became oxidized. Therefore, this is the Ra, the reducing agent, because it got oxidized. Okay, next up, let's see if we can find something else that maybe is oxidized or reduced. Well, the other ion that I see that stands out is I see Mn2 plus. Mn2 plus, and then over here we've got, well, oxygen, that's a 2 minus charge each. There's 4 of them, so that's going to be -8. What plus -8 gives an overall charge of -1? Well, that would be manganese with a +7. So this has gone from a +7 to a -2. How is that happening? Well, that is happening by gaining electrons, 5 of them in fact, and by gaining 5 electrons, that means that manganese became the oxidizing agent. So that's one way to do it. Another way is just to kind of see patterns and see, okay, well, this metal is getting oxidized, therefore it is the reducing agent. This metal is getting reduced, therefore it is the oxidizing agent. as you practice this more, you'll get more comfortable with it. But this will be helpful, again, on those early homework problems, but just the general understanding of this will basically get you through questions 1 through 8 pretty seamlessly. All right, have a good one.